So in this video I'm going to talk about differential equations, or in particular linear differential equations. So we will begin with the form of linear differential equations, which is a1 of x. So this is the function, a1 is the function of x times dy dx plus a0 of x times y, which is equal to g of x. So this is equation 1, and we will divide both sides with a1 of x. So we have dy by dx plus a0 of x, a1 of x, times y, which is equal to g of x divided by a1 of x. So we will write a of x divided by a1 of x, which is, we call this p of x, and g of x divided by a1 of x, we will call this f of x. So now this equation will look like dy by dx plus, this one is p of x times y divided by f of x. So this is the equation number 2. Now, how we can solve this equation? So we will begin by we multiply this equation both sides by one function mu of x. So this is other function, function. So first first we have to multiply this equation by this function, and in the end of this video I can show you what is this function, how we can know with what function we have to multiply. So d by dx, which is mu of x times y, is equal to mu of x dy by dx plus d mu of x by dx times y. So this is in right hand side, this is equal to the mu dy by dx plus mu of x times p of x times y. So we look, this is equal to this one, and this one is equal to this one. So we know that d mu of x divided by dx, is equal to mu of x times p of x. So I have to write, so this one I have to write also again, d mu of x dx mu of x times p of x. And so we separate the variables, so we have d mu of x divided by mu of x, which is equal to p of x times dx. This one is natural logarithm, or ln of mu of x, which is equal to integral of px times dx plus c. Only mu of x is equal to e in the power of integral px dx plus c. So we know that in example we can know the px, the function px, we plug here and we find ux, and we multiply that equation with u of x. But we have other thing to do before going to solve an example. So the next step is to find the solution of differential equation. So we have to do a little calculation. So dy by dx plus px times y. So this is y. This is equal to f of x. So we multiply both sides by mu of x, which is equal to a in power p of x dx plus c. So a in a integral px dx times du by dx. So we can say that the constant is 0 for simplicity, plus p of x times a in a power px dx times y, which is equal to a in an integral of px dx times f of x. So the right hand side we can write as the product rule. For example, d by dx of an a in a power px dx times y, which is equal to the integral of px dx times f of x. We know that the derivative of a in the power px dx is px dx, so we have like this. And now we can write e in the integral px dx times y, which is the integral of e in the integral px dx times f of x dx. So this is the other integral. This thing in whole integral times with f of x. So y is equal to a in minus p of x dx times the big integral e integral px dx times f of x dx. Oh, sorry. So this is the solution, the whole solution. So if you know px, if you know f of x, so you plug here px, here px also, f of x plus constant c, you can find the solution of y. But this is I don't like this method. I like doing the calculations. For example, we can do dy by dx minus 3 times y, which is equal to 0. So f of x is 0. P of x is minus 3. So u of x is equal to a in a px dx, a minus 3 dx, a minus 3x. So mu of x is a in a minus 3x. So we multiply this equation here by this function here. So dy by dx minus 3 times y, which is equal to 0, both sides by 8 and minus 3x. 8 and minus 3x times dy by dx minus 3 times e to the minus 3x times y, which is equal to 0. So we can write the left hand side d by dx a to the minus 3x times y, which is equal to 0, and we integrate both sides. So we have a to the minus 3x times y equal to constant, or c. We have here y is c times a to the 3x. So this is the solution of this differential equation. We have other equations, for example, x times dy by dx minus 4 times y x to the 6 times e to the x. First thing that we have to do is to leave this part alone, so to leave only dy by dx. So we have to multiply both sides by x. Dy by dx minus 4 over x y minus equal x to the 5th times e to the x. So we know that p of x is minus 4 over x. We know that f of x is equal x to the 5 times e to the x. So u of x is equal a in the integral minus 4 over x dx, which is equal to a to the minus 4 integral dx divided by x, which is equal to a in a minus 4 times ln of x, and this one is equal to mu of x is equal to a ln of x in a power minus 4, because this number goes up here, and the mu of x is equal to x in a power minus 4. So we multiply this whole equation here. This one here, by this function. So we find x to the minus 4 dy by dx minus x to the minus 4 times 4 divided by x times y, which is equal to x to the 5th power e to the x times x to the minus 4th. So this, okay, I will do one further step. X to the minus 4 dy by dx minus 4x to the 5th y times y is equal to x times e to the x. The left hand side we can write d by dx of x to the minus 4 times y, which is equal to x times e to the x. So now we integrate both sides, and we have x to the minus 4 times y, integral x times e to the x. This integral has to be solved by integration by parts. So you take here is the x. You take e to the x with u, and x dx equal to dv, or you have to change. For example, you have to change the v and u. It depends. So now this integral is x times e to the x minus a to the x. So you have to prove this by partial method of integration. And from here, the plus c, there is a plus c here. Y is equal to x in a power of fifth power times e to the x minus x to the fourth times e to the x plus c times x to the fourth. So this is the solution of this linear differential equation. Why this is called linear? Because this is the first order of x, so x in a power 1. We have the second order, third order, and n order of differential equations. So thank you very much for watching.